Well, hi everyone. Thanks for coming back. I'm here with my friend and colleague Murray Middleman. This week we've been talking about cross-sectional study designs. And what we'd like to give you now is an opportunity to read a paper that used a cross-sectional design and discuss some questions. And I've asked Murray to take us through that process. He's chosen a paper, developed some questions. He'll be talking about that in a few minutes. But first, I think it would be useful if Murray could tell us something about himself. Murray, you're a physician, a cardiologist, still a clinician, but you're also a full-time epidemiologist. When did you decide to become an epidemiologist? When did the light go off that this is the field I want to be in? Could you share some of that with us?
Sure. So earlier in my training, when I was a medical student, I had done some basic science research around cardiac electrophysiology and pharmacology research. And it was later on, after completing all of my clinical training, that I decided to pursue some coursework in epidemiology. And truthfully, I had started taking some classes when I was at McGill and came to Boston and to get more advanced training. And actually the first epidemiologist that I encountered was Fran, and he inspired me to enter the program. And truthfully, after a couple of weeks of the program here, I completely fell in love with the field and decided to stop what I had been doing, which was working as a clinician educator, and to pursue a doctorate in epidemiology. And I've been doing it ever since. And I have to say, one of the things that I always say to our students is that, if it's not fun, it's not epidemiology. And it really has been a great ride for me, and hopefully it will be equally fun for all of you. So what I'd like to do now is to move on and introduce you to the material that we'll be covering today. And as Fran said, we're going to be talking about a critique of a cross-sectional study. And the study that I chose is the paper that's listed here on lead and cadmium levels and its relationship to balance and vestibular function among adult participants in the National Health and Nutrition Examination Survey, or the NHANES survey, with data collected between 1999 and 2004. This paper was recently published in Environmental Health Perspectives at the beginning of 2012. Now, before we start reviewing the study itself, I would just like to say a few words about cross-sectional studies in general. So the first thing to think about with cross-sectional studies is that cross-sectional studies are designed in such a way that we're collecting all of the data on the exposures and the outcomes and the covariates, potential confounders, and so on, at a single point in time. One of the things that's important when we think about time in epidemiology is that sometimes time can be measured on different time scales. So sometimes by time, we mean calendar time, defined based on a particular date that occurs. On the other hand, we can also think about a time scale corresponding to age. So I can look cross-sectionally at a cohort of 50-year-olds who were accrued into my study over a period of 3 or 4 calendar years. It's still a single point of time when I think about the time scale being age. Another common time scale that's used in epidemiologic studies are times of a life event. For example, what is the prevalence of cancer at the time of death? If we were to look at autopsy studies, we have a particular point in time in a life course. Another example would be looking at a cross-sectional look at all of the data in a study, let's say a randomized trial, and we look at the data at the time the patient or the subject enrolled in the study. So the day they signed the consent form to enter the study, I can look cross-sectionally at that point in time. And in this case, once again, my time scale is the date of enrollment in the study, and taking into account the fact that that might occur over a broad range of calendar time or a broad range of age. So when we think about epidemiologic studies, not only cross-sectional studies but longitudinal studies, we always have to think about what time scale we're considering in evaluating the data. Now, in cross-sectional studies, we are evaluating the exposures and the outcomes and the covariates all simultaneously. As a result, the natural measures that we look at in terms of disease frequency is going to be the prevalence, the number of cases of a particular disease that's present at that point in time. Likewise, the measures of exposure are also looked at a single point in time. They're not looked at longitudinally. We're looking at the measures at that same point in time that we measure the outcomes. This allows us to look cross-sectionally at the same time point at the relationship between exposures and outcomes, or across different characteristics of an individual. So different exposures may be looked at cross-sectionally in terms of their relationship with each other. As a result of this design element of not having a longitudinal component, it leads to some of the limitations of doing cross-sectional work in terms of what implications and what inferences we can draw from the results of such studies. The first thing to think about is because the exposures and the outcomes are measured simultaneously, it's not always possible for us to use the data to draw cause-effect relationships, because it's sometimes difficult to know which came first, the exposure or the outcome. I can give you an example of that from some work that I've done in the past. Early in the days when we were interested in the relationship between inflammation and diabetes, we hypothesized that individuals with chronic inflammatory conditions would have a higher risk of diabetes. The data we had available to us was data from NHANES, for the data set that we're going to be looking at in this study, and we asked the question, is there a cross-sectional relationship between the prevalence of having rheumatoid arthritis and the prevalence of diabetes in that population that reflects the distribution in the US population? Now, we did see an association, but from that we can't tell whether the diabetes came first or the arthritis came first, because we're measuring it simultaneously. Another limitation of cross-sectional studies is that they will tend to overrepresent individuals who have a longer duration of disease. Imagine, for example, one where it's interested in the relationship between a particular genetic marker and the incidence of childhood leukemia. If one did a cross-sectional study looking at children being followed in a hematology clinic with that particular form of leukemia and measured the genetic marker in that population, if you found that there was a higher prevalence of this particular genetic marker in the population compared with the prevalence in a similar population of children who do not have leukemia, it could be that this genetic marker is associated with a higher risk of developing leukemia. On the other hand, it's also possible that this genetic marker is a predictor of response to therapy, and therefore children who have this genetic marker may be more likely to survive long enough to be in the population when we sampled it. So it's equally likely that this genetic marker that we find to have to be more common among children with the disease may be because it's associated with the incidence of disease, or perhaps with improved survival and a longer duration of disease. And from the cross-sectional look, we really can't determine which of those competing alternative hypotheses is correct. What I'd like to do now is share with you the data source that's used in the paper under consideration for review today. The paper that we've chosen is based on data that was collected as part of the National Health and Nutrition Examination Survey, or NHANES, and these are data that are publicly available and useful for evaluating a variety of questions. What I'd like to do is show you the website. So here is the web address. So if we go to the website that we have on the slide here, we end up at the National Health and Nutrition Examination Survey page, which is run by the Centers for Disease Control and Prevention. And on this web page, we have all of the information available to you that you would need if you were to undertake a new study. If we look at the first page, we can get some general information about NHANES. If we click on the link about NHANES, we see further information, including an introduction to NHANES, some of the background, and some of the information that's contained in the different surveys over time. In addition, if we click on the link questionnaires and data sets with related documentation, we jump straight to a page that includes a document that describes how to conduct the analyses using NHANES data, and a web tutorial that walks you through how to download the data and manage the data to conduct such a study. And this is followed by a table that includes a list of all of the variables that are included in each of the different data sets to allow you to have an idea of what sorts of questions could be addressed using this publicly available data set. And then finally, we have all of the data that's been collected over the years and fully available and downloadable with a simple click on these icons, which then brings us to the actual data sets as well as data dictionaries that explains exactly what's in each of the data sets. So this is something that is freely available, very powerful because it explores a very broad range of exposures and outcomes cross-sectionally, and importantly, is drawn in a random sample, as a random sample from the U.S. population, and so the results can be generalizable to the U.S. population when the analysis is done correctly. I'd now like to just review a few points about the paper that we'll be reviewing. As I said before, the paper is about lead and cadmium levels and balance and vestibular dysfunction among adult participants in the National Health and Nutrition Examination Survey. And the authors undertook this study based on the background that there was observations that exposures to heavy metals, including cadmium and lead, were associated with adverse neurobehavioral outcomes, including hearing loss. But there was little known about this relationship to balance and vestibular function. But there was a pretty strong prior hypothesis that it would affect the nerve functioning of the inner ear, leading to the hypothesis that it may affect balance. In this study, the authors used data from the National Health and Nutrition Examination Study to conduct the cross-sectional relationship. The outcome that they used in this study to evaluate balance and vestibular function was something called the Romberg test. And if you click on the link here to the YouTube video, you can see a video of how this test is conducted.